Well, so here we are ready to get started with chapter 17 that deals with the alcohols and phenols. Well, alcohols, we have learned in the early chapters about nomenclature. Whenever you have an alkyl chain and you have an OH attached to one of the carbon atoms, so that constitutes an alcohol, right? Alcohol. And you can have the OH group attached to a terminal carbon atom of the chain or to one of the uh, carbon atoms that is within the chain. Uh, then we have some classification here depending on whether the OH is attached to just a regular carbon atom. As I said, it could be primary, secondary, or tertiary carbon. Or if you have the OH attached to an sp2 carbon of an aromatic system, like in this molecule that we call phenol. So instead of calling them alcohols, sometimes you will find that they will refer to those as aromatic alcohols, but the more general name that we give to those is phenol. So phenol is the name of that particular compound, but we can also use that name as a generic name for any structure that will contain a benzene with an OH. It doesn't matter if it has some other embellishment here, we will still say that is a phenol. It belongs to the same category. And then finally, we have here another category of when you have an alkene. The alkene could be somewhere in the middle like this. And then if you have an OH group attached to one of the carbon atoms of the alkene, in that way, in that case, we say there we have an enol. Enol because you have an alkene here, right? You have an alkene in this portion, and you have an alcohol at the same time. We met that kind of compounds in the chapter of alkynes. When we perform a hydration of an alkyne, we saw that the product that you obtain initially is an enol, and then later on that enol may tautomerize to an aldehyde or to a ketone. So a little more on a classification of alcohols. If the OH is on a carbon atom that is attached to only one other carbon atom, like here, for instance, you may have a CH3 group there. And so the carbon atom that is attached to the OH is attached to only one other carbon atom. We call that a primary alcohol. If you have the carbon atom attached to the OH, in turn attached to two other carbon atoms, in that case we say that is a secondary alcohol. And if it is attached to three other carbon atoms, that is a tertiary alcohol. It is a useful classification that because it turned out that primary alcohols, secondary alcohols, or tertiary alcohols, they have a different reactivity. And so it will be good to be able to differentiate those. So here I have a question for you. What kind of alcohols are the following compounds? So this first one here, because the OH is on a carbon atom that is attached to only one carbon atom, so that will be primary. The second one, the carbon atom that is attached to the OH is attached to three other carbon atoms. So this will be a tertiary alcohol. And then this one here, the last one, the OH is attached to a carbon that in turn is attached to two other carbon atoms. So this will be a secondary alcohol. Nomenclature. So we need to know how to name alcohols. Well, business as usual. So you choose the longest chain that contains the OH, the functional group. And let's say that if you have a structure like this, so what will be the name of this? So the name of this will be, we have 1, 2, 3, 4, 5, 6, 7. So that will be a heptanol, right? Heptanol. And I need to indicate the position where the OH is. So that will be 3-heptanol. And because I have some other kind of embellishment there, I have a methyl group in the carbon 2. So the complete name of this will be 2-methyl-3-heptanol. In addition, it will be necessary to indicate the stereochemistry. So if I have chirality centers, I will have to take care of that as well. So here we have a few examples, 2-methyl-2-pentanol. So I try to give the smallest number to the carbon atom that contains the OH. How about if we have more than one OH? So in that case, the compound will be called a diol, right? We have a diol. If the compound, the base compound is a ring, so it will be cyclohexane diol because we have two OHs in the compound. And also we will need to indicate the relative stereochemistry of those groups. So here the two OHs are in the upper phase of the molecule, so we say, this is the cis-1,4 cyclohexane diol. So as I indicate here, you need to indicate cis or trans or R or S when you have some stereochemistry in this molecule. There is quite a number of alcohols that they have some trivial names, like a benzyl alcohol. Benzyl because, well, when you have a carbon atom that is one carbon away from the benzene ring, so we say that is a benzylic position. So if the OH is attached to that carbon atom, so that will be benzyl alcohol. Allyl alcohol, same idea. So you have a carbon-carbon double bond, the carbon atom that is one carbon away from the carbon-carbon double bond, that is an allylic position. So when the OH is attached to that carbon atom, we say that is allyl alcohol. Another with trivial name is terbutanol, or we can refer to that also as terbutyl alcohol. We have some special diols like ethylene glycol, that is the liquid that you add in the radiator of your car, right? Ethylene glycol. So glycol is when you have a vicinal diol. And then another polyalcohol of interest is glycerol. Glycerol, that is the base compound for some fats in biological chemistry. So you can make esters out of those, and those are the fats, right? And then finally, we have here some special nomenclature for aromatic systems. We have phenols. And here we will learn in the second semester that when you have more than one substituent in a benzene ring, if you have a relationship 1,2, so we say that is an ortho relationship. So and because of that, this compound here, that we can call it 2-bromophenol, 1, 2, we can also call it ortho-bromophenol. A 1,3 relationship, so if you have substitution in the position 1 and substitution in the position 3, so we call that meta. That's why here, for the first compound, we will call that meta-chlorophenol, because the chlorine is in a 1,3 relationship with respect to the OH. And then when you are in a relationship 1,4, like here, 1,4, we call that para. Para is opposite, 1,4 para. So that will be 4-nitrophenol or para-nitrophenol. If you have more than two substituents, there you need to use the numbers for indicating the position of each one of them. In this next slide, we have a little discussion about the physical properties of alcohols. Because in an alcohol, you have an ROH, so you have the hydrogen that is attached to a highly electronegative element, oxygen. So because of that, you have a very strong delta plus on the hydrogen and a very strong delta minus on the oxygen. And because of that, you can form hydrogen bonding. And that will explain why alcohols and phenols also, they can form hydrogen bonding, and the boiling point of those compounds are substantially higher than the boiling points of other molecules like hydrocarbons or ethers of a similar molecular weight. For instance, propane, this is propane, it has a boiling point of minus 42, minus 42. Then we have a dimethyl ether, so that will be that compound. It has a boiling point of minus 24 degrees, minus 24 degrees centigrade. And ethanol, it has a boiling point of 78, so it's much, much higher boiling point. Similarly, the phenols, you have a phenol like this, the boiling point is 182, 182. But if you get the corresponding ether, the ether with the methyl group there, now the boiling point falls to 153. So even though the molecular weight is higher, still the boiling point has a very important decrease. Okay, so I will stop here and we continue later.